Welcome back to our channel. Today we will discuss about the limits of rational function. Let's take a rational function f of x equals g of x by h of x, where h of x not equal to 0. Here h of x and g of x are polynomial functions. This is known as a rational function. We have a rational function f of x that equals g of x by h of x, where h of x not equal to 0, g of x and h of x are polynomial functions. This is known as a rational function. Now apply the limit. Limit x tends to a f of x equals limit x tends to a g of x by h of x. Here we apply algebra of limits. That means apply the limits separately. So apply the limit to the numerator and to the denominator. Limit x approaching to a g of x by limit x approaching to a h of x. Limit x approaching to a f of x equals f of a. We have explained this equation already in the previous video. This is only true for the polynomial function. Limit x tends to a f of x equals f of a. That means finding the limit of the function. Finding the limit of the function means finding the limit of the polynomial function is equal to the direct substitution of the value. We have explained this equation, the proof of this equation in the previous video. In this case, g of x and h of x are polynomial function. So, we apply limit x tends to a f of x equals f of a, this equation. Is it clear? So, apply that equation to this, we get limit x tends to a g of x becomes g of a and limit x tends to a h of x becomes h of a. So, limit x tends to a g of x by h of x equals g of a by h of a. This is the limit of rational functions. Then we have three cases based on the value of g of a by h of a. Case 1, g of a equal to k and h of a equal to 0. Then limit x tends to a f of x becomes, applying the values here, k by 0 equal to infinity. Anything by 0 becomes infinity. Case 2, g of a and both g of a and h of a are 0. Then limit x tends to a f of x equals 0 by 0. Case 3, g of a equal to 0 and h of a equal to k. Limit x tends to a f of x equals 0 by k. 0 by anything is 0. These are the three cases. Case 1 we got infinity. Case 2 we got 0 by 0. Case 3 we got 0. These are the three cases that we apply the values. Based on the values of g of a by h of a, we got three cases. Infinity, 0 by 0 and 0. These are the three cases. Now, we have to explain these three cases in detail. First, case 1. Here, g of a equal to k and h of a equal to 0. Then, k may be any value. It may be some real number and h of a equal to 0. That means limit x tends to a f of x equals g of a by h of a. Then apply the values here. Then g of a equal to k and h of a equal to 0. This becomes k by 0. Anything by 0 is infinity. Then whenever we got infinity, we say that the limit is undefined or the limit does not exist. In this situation, for the rational numbers, the limit does not exist or the limit is undefined. This is case 1. Now, for example, limit x tends to 2, x cube minus 2 by x minus 2. Apply the limit directly. X tends to 2, x cube means x cube becomes 2 cube. 2 cube minus 2 by 2 minus 2. 2 cube means 2 into 2 into 2. Multiply 2 3 times. That is the meaning of 2 cube. So 2 cube is 2 into 2, 4. 4 into 2 is 8. 2 cube is 8. 8 minus 2 by 2 minus 2, 0. 0. That is equal to 6 by 0. That is equal to infinity. Here, g of a equal to 6 and h of a equal to 0. So we got infinity. Here, what is the conclusion here? Here, the limit does not exist or undefined. This is the example of case 1. Now, case 2. Here, h of a equal to 0 and g of a equal to 0. Limit x tends to a, f of x equals g of a by h of a. That is equal to 0 by 0. Whenever we got 0 by 0 form, then we need to factorize. Whenever we got 0 by 0, then what will we do? We need to factorize or apply the factorization method. When we apply the limit, in certain case, we may get 0 by 0 form. When we get 0 by 0 form, we can leave that problem as it is. Instead of that, we have to apply the factorization method. Is it clear? Whenever we got 0 by 0, we need to apply the factorization method. For example, limit x approaching to 2, x square minus 4 by x minus 2. That is equal to x. Apply the limit directly. So x square becomes 2 square. 2 square minus 4 by 2 minus 2. 2 square is 4. 4 minus 4 by 0. That is equal to 0 by 0. Whenever we got 0 by 0, we need to apply the factorization method. So here this is a rational function. This is in the form of g of x by h of x. Now here apply the limit directly, then we get 0 by 0 form. So we have to factorize. So limit x tends to 2 x square minus 4 by x minus 2. X square minus 4, that is equal to x square minus 2 square. Now x square minus 2 square is in the form of a square minus b square. A square minus b square can be factorized as a plus b into a minus b. So x square minus 2 square can be factorized as x plus 2 into x minus 2. Now x plus limit x up tends to 2, x plus 2 into x minus 2 by x minus 2. These x minus 2 get cancelled. Then we got limit x approaching to 2x plus 2. That is equal to 2 plus 2. That is equal to 4. Here we apply the limit directly. So whenever we got 0 by 0 form, we need the factorization method. Then we got the answer 4. So clear? Then case 3. In case 3, g of a equal to 0 and h of a equal to k. That means limit x approaching to a f of x equals limit x approaching to a g of x by h of x. Then this becomes g of a by h of a. Then apply the value here, g of a equal to 0 and h of a equal to k. K indicates some value. Then 0 by k equals 0 by anything, that is equal to 0. For example, limit x tends to 2, x minus 2 by 2x plus 2. Apply the limit directly, that is equal to x becomes 2. 2 minus 2 by 2x becomes 2 into 2 plus 2. That is equal to 0 by 4 plus 2. 0 by 6. That is equal to 0. 0. G of a equals 0 here and h of a equal to 6. The value of k here is 6. So we got 0. So clear? This is the example of case 3. That is, we conclude that limit x approaching to a f of x equals limit x approaching to a g of x by h of x, that is equal to g of a by h of a. Based on the values obtained in g of a by h of a, we have 3 cases. Case 1, h of a equal to 0, g of a equal to k, then we get k by 0, that is equal to infinity. In this case, the limit does not exist. Case 2, h of a equal to 0 and g of a is equal to 0. Both of them are zeros. Then limit x tends to a f of x equals 0 by 0. In that case, apply the factorization method. Case 3, g of a equal to 0 and h of a equal to k. That is equal to 0. In this case, limit value is 0. There are three cases. There are 3 cases. First one, the value got as infinity. Second one, 0 by 0. Third one, 0. These are the 3 cases. Is it clear? Thank you.